Talk to you guys about strong acids and strong bases today in the pH scale. All right, and you'll hear the term strong acid and strong base, and you're going to hear the term pH scale. And if you look on the back of that sheet of paper, it gives you the pH scale, which is 0 to 14. And up here I've outlined that a strong acid is considered 0 to 3 on the pH scale. A weak acid is considered 4 to 6. Neutral, okay, and we're going to explain what neutral means in a minute, but neutral is 7, and then a weak base is 8 to 10, and a strong base is 11 to 14 on the pH scale. All right, now, what does that mean to be a strong acid? What it means is that it's going to ionize, which means break apart into particles quickly and completely. And you'll always know it's a strong acid because there's one arrow. All right, these are the strong acids, okay, that you're going to have to be able to see or recognize. But the biggest thing is you'll know it's a strong acid in the formula when there's only one arrow. So HCl is going to get broken down into H plus and Cl minus ions. That's ionization of HCl, and it does it quickly and completely. A weak acid is one that ionizes slowly and partially, and you'll always be able to tell because there's two arrows, one going one going the other way. Okay, so these are our list of our weak acids. Okay, and when they are seen, you're going to see that when they ionize, they only do it partially. Okay, and so one arrow is going this way, one's going back. So there's two arrows, and it's kind of like a weak leader is like wishy-washy. So it's going back and forth and back and forth. A strong leader just goes one way and goes forward, right? Well, weak acids go back and forth. So it breaks into H plus and F, but then it kind of reconnects back into HF, and then it goes back. So back and forth. A strong base is one that dissociates and quickly and completely, just like a strong acid. There's always going to be one arrow. Dissociate is pretty much the same word as ionize, except it happens with ionic compounds. So it breaks into ions. All right. So if I have NaOH, it's going to dissociate into Na plus and OH minus. Okay, and it's going to do it with one arrow, so it does it quickly and completely. And then that is a list of your strong bases. All right, and then the last thing is weak bases dissociate slowly and partially, just like weak acids, except instead of ionizing, they dissociate. And there's going to be two arrows again. And the easiest weak base to talk about is NH3. Right? NH3 plus water is going to make NH4 plus and OH minus. We talked about those yesterday with conjugate acids and conjugate bases. Now, as far as strong and weak, okay, you can see they're on opposite ends of the pH scale. All right? So what is pH? pH is it's the measure of the concentration of H plus ions. All right? So pH equals the negative log of the hydrogen concentration. All right, so the concentration of H plus ions. When you see that, I want you to think of H plus ions as acid ions. When you see the term pOH, that's going to equal the negative log of the OH, which are minus hydroxide ion concentration. So I want you to think of hydroxide ions as base ions. All right? So the pOH is measuring the base ions. The pH is measuring the acid ions. All right? Now, we see this concentration thing. What does that mean? All right? Well, with neutral water, all right, with neutral water, you're going to see it's going to have a pH equaling 7. Well, what does that mean? That means that you have 0.000001 concentration of H plus ions. If the pH equals 7, you're going to see that the pOH will also equal 7 because pH plus pOH is going to equal 14. And that's going to be a constant that we're going to have to know. All right, so the good thing about that is it's always easy to tell. If you know one, if you know the pH, you can always find the pOH. If you know the pOH, you can always find the pH. All right, but when there's 7, they're going to be equal. So if you look at these numbers, you can see that their concentrations of the H plus and the concentration of OH minus is equal. All right, so what does that equal? That equals the concentration of H plus. That equals the concentration of OH minus. Acid ions, base ions. So what does it mean to be an acid? Okay, what it means to be an acid is if I have something less than a pH of 7. So if I have a pH of 6, watch what happens to the concentration. Now it's 0.000001. Okay, so that's 1 times 10 to the minus 6. Okay, and that's going to make my pOH be 8. Okay, so now look. So now, if you look at it, my concentration of H plus ions is bigger, not by much, but it's bigger than my concentration of OH minus ions. So I have more H plus, which makes it an acid. Now, when you get really strong acids, like a pH of 3, now it's going to be 0.001 for my H plus concentration, and my OH concentration is going to be equal to 14 minus 3, which is 11. So it's going to be 10 zeros and a 1. All right, so when you look at that, you can see, okay, that the H plus concentration is a lot more than the OH concentration. It's 800 million times more. That's a lot. Okay? So, So my point is there is a lot more H plus concentration in there than there is OH minus, and so that is a strong acid. And vice versa with a base, if my pH equals 11, then my pOH is going to equal 3. So my pH is going to be that, and my pOH is going to be that. So now which one is there more of? There's more OH minus, right? So if there's more OH minus ions, then that is a base. So if a pH equals 11, then my H plus concentration equals that, and my pOH equals 3, then my OH concentration is that. So whichever one there's more of, if there's more OH concentration, that is a base. If there's more H plus concentration, that is an acid. And so now what we're going to talk about is how do you convert into pH from pOH, and how do you convert into pH from the concentration? Okay, stop.